guys. Not with you live today, but I will speak to you properly on Monday. But we've got to get through today, to be honest. We're trying to finish transformations. So far we've done reflections and we've done rotations. We're going to try and get through the final two today, and they are translations and enlargements. Okay, so you need to put a title today of translations and enlargements, and then a subtitle of translations. Okay, we're going to look at those first. Okay, so you need to know what a translation is really. So a translation is when a shape is simply moved, okay, and it remains. That says remains in the same orientation and width and size. Okay, so it stays exactly the same, you're just moving it somewhere else. And we describe this movement. Using vectors. Okay. So translation is when a shape is simply moved and it remains in the same orientation and size. We describe this movement using vectors. And you'll see in a minute what a vector is, but a vector is written like this, and the top number we call the x number and the bottom number we call the y, and the top number is the left/right movement, and the bottom number is the y, and it's the up or the down movement. Okay, so e.g. a vector 3 minus 1 would move a shape, or let's not use the word move, let's say would translate a shape 3 to the right because it's positive and 1 down because it's negative. Okay, so if this is the top number is positive, it goes to the right. So right is a positive number, left is a negative number, up is a positive number on the bottom, and down is a negative number on the bottom. Okay, so a little bit of notes there, so you might want to pause the video at this stage, but we're going to look at an example now, e.g. 1. Okay, so do pause the video if you need to and copy those down. So this is the sort of question you might be faced with even at GCSE. So it says translate D, which is this shape, by, and it just says minus 3, minus 2. Now, the top number, you should know now, that is left and right, and that's left because it's negative. It's going in the negative direction, and that means it's going to go down 2 units because that's the bottom number, and it goes down. So we go through each point carefully. So this point is going to go left 1, 2, 3, and down 2. So that point will go there. This point, left 3, down 2, there. This point, that point, there. And then I can draw the new shape there. And we usually label it the same letter but with a dash to show that's the image. Okay, this is called the object. That's the original. That is called the image. That's where it's moved to, and it should be exactly the same, just in a different shape. So that's what it means by translation, and that's what it means by a vector. So it says here, we've got a different question here. Describe fully the transformation that takes it from shape A. How do I get from shape A to shape B? Now, it's just moved. It hasn't rotated, it hasn't reflected or anything like that. So it is a translation. So you get 1 mark for identifying the sort of transformation it is. It is a translation by the vector. So how am I getting from shape A to shape B? Well, I need to look at some corresponding points. How does that point go to that point? It goes 1, 5 to the right. So it's 5 to the right. So I'm going to put 5. That means 5 to the right. And how many up? 4 up, so it's by the vector 5, 4. So we don't say 5 squares left or 5 squares right and 4 squares up. We write it as a vector like that instead. It's much more mathematical and quicker to write it in that way. Okay, at this stage you might want to sort of stop the video, get the notes down and start on the translation sheet. I think you'll find that translation sheet quite easy. Translations tend to be the easiest out of the 4 transformations. Okay. Right, once you've done that, we're going to move on to enlargement. So you want to put a subtitle enlargement. Okay. And we need some subtitle enlargement. And for enlargement, so we need some information. We need the scale factor. We need the center of enlargement. Okay. Now the scale factor tells us how much bigger or smaller the object becomes. There are some scale factors. If you have a fractional scale factor, so like a half or a third, the object actually gets smaller. So it's still called an enlargement even though it's getting smaller. And the center of enlargement tells us where the object will go. Okay, so here we've got a question. And it says something like this. It says, enlarge the rectangle by scale factor 2 using the center of enlargement. So I know that it's going to be twice as big because it's a scale factor of 2. So I could, if it didn't say using a center of enlargement, I could draw it anywhere I wanted. I could draw it. It's twice as big, so it's going to be 8 squares across. Don't bother filling this in because it's different to what we're doing. And then 6 squares up. See, I drew a ruler. If I want, that would get me half marks because that is a scale. And in some questions, it won't have a center of enlargement, and you can draw the image anywhere you want. Okay, so that is, if it just has a scale factor, you can draw it anywhere you want, and that is going to be twice as big because it's scale factor 2. If it was scale factor 3, it would be 3 times bigger. If it was a scale factor half, it would be half as big, and so on. Now, this has a center of enlargement though. So it's a center of enlargement minus 1, 0. So I'm going to put minus 1, 0. And remember, the first digit's x, second digit's y. So minus 1, 0 is there. I'm going to make that nice and clear on my sketch, okay? Now, at this point, I'm now going to label the corners because that's going to really help me. It doesn't matter how I label them, but I'm just going to label them like this. If it doesn't matter, don't be worried about it. You can call any of the corners any letter. It doesn't have to be in any order, okay? Now, for each one here, so to get to A, how do I get to A from the center of enlargement using vectors? Okay, so from the center of enlargement, I go 1 to the left, sorry, and 2 up. I go 1 to the left, so it's -1, and 2 up, 2, okay. Let's just do this for each of the points. To get to B, I'm going to go 1, 2, 3, and then 2 up, so 3, 2. To get to C, I go 1, 2, 3 across, 1 down, so -1. And to get to D, I'm going to go 1 to the left and 1 down, so -1, -1. Now, to get my new points, I times this by the scale factor. Times by the scale factor. In this case, it's 2. It won't always be 2, but in this case, the scale factor was 2. Now, if I times a vector by 2, I just times the whole thing by 2. So this is going to be -2, 4. I'm timesing -1 by 2 and 2 by 2. Times that one by 2, I get 6, 4. Times that one by 2, I get 6. -2. Times that one by 2, -2, -2. And these are the new vectors. This will tell me where these points are going to go. So for A, my new A, which is down the right side there, I'll go back to my center of enlargement. I'm going to go -2, and I'm going to go 4 up. 1, 2, 3, 4. And I'm going to put a point there, and I'm going to label that A dash. That's where my new A has gone, and I've done that one. Next one is 6, 4. So I'll go back to my center of enlargement, count 1, 2, 3, 4, 5, 6, and then 4 up. and I put a point there. That's going to be my B dash, and I've done that one. And so on. I'm going to go C now, 1, 6, and then 2 down. That is going to be my C dash on that one. And D goes there. And then at this point, I can just join all the points together. And that is exactly what I'm after, okay? It's twice as big and it's in the right location based on this centre of enlargement. So I need to use vectors to do that. So I can answer all of those questions like that now, just using vectors and filling in that table like I've done on the right side there. Again, do pause the video if that is a really useful example to get in your notes. Right, the final bit, which concludes enlargement, so describing an enlargement. A subtitle may be describing an enlargement. And we've got this shape here. It is, if you've got squared paper, it is worth copying these up so you've got really good examples in your book. Okay. So it says describe fully the transformation that maps. How do I get from A to B? How do I get from A to B? Now it's getting bigger, so I know immediately it's an enlargement. That gets me 1 mark. These are GCSE questions, by the way. It's enlargement. By the scale factor, you can answer these in bullet points. How much bigger is it getting? Well, you compare the lengths of the line. So that's going to be 2 squares, that's 4 squares, it's double. So it's a scale factor 2. And then I need to find the centre of enlargement. Now to do this, I use what I call ray lines, okay, which is really cool, but it means I find the corresponding points, so these two, and I draw a nice line between them. Hopefully a little bit, yours might be, it's a bit easier with a ruler, but okay, so that's 1. I'm going to draw it now from that point through that point. Again, hopefully it's a little bit clearer than mine. Okay, not super. And then the next one, I go from that point through that point, corresponding points, so that point to that point. And they will, if you've done this properly, mine is sort of a little bit pixelated, they will cross at an exact point, and that point, if I did do it properly, should be 7, 6. So centre of enlargement is going to be 7, 6. Okay, and that, guys, is all of translations, all of enlargements. Okay, so you can now print off those 2 worksheets I've put on Show My Homework and work through them, please. The answers are all also there so you can check your answers as you go. And I will see you again, guys, for our final week next week, but I'll tune in on Monday, please, and I'll speak to you then about what we're going to do on Monday. Okay, well done, guys, and speak to you soon.